Hi there, I'm Brian Issa. A warm Namibian welcome to all advanced subsidiary level mathematics learners and everybody interested in learning maths. We appreciate your company. This is the fifth and final video lesson in a series of differentiation of functions. After today, we hope that you have this topic firmly mastered. So with this lesson on differentiation of functions, we'll take you through the steps to separate fractions, to simplify functions before we differentiate, and then differentiate rules by applying usual differentiation rules to solve given functions problems. Let's get started. We are going to do differentiate y is equals to ax to the power of m plus b over cx to the power of n. We'll do it in three steps. Firstly, simplify the fractions before differentiating. Rewrite the function as separate fractions. They are separated by plus or minus. Separate the two terms in the numerator into fractions with the same denominators. Y is equals to ax to the power of m over cx to the power of n plus b over cx to the power of n. Take a moment to see how this was done on the screen. Use the laws of indices to simplify each fraction to get y is equals to a over c x to the power of m minus n plus b over c x to the power of negative n, so that there are no x's in the denominators. From here we start differentiating the two separate fractions. Y is equals to a over c x to the power of m minus n and b over c x to the power of negative n. In the usual way, by multiplying the terms by the exponent m minus n and negative n, and then deducting 1 from the exponents m minus n and negative n. So we differentiate to get dy dx is equals to a over c m minus n x to the power of m minus n minus 1 minus b times n over c x to the power of negative n minus 1. There is done. Take a few moments to look at the final step again. Make sure you can follow this process. We will do these three examples to practice simplifying fractions before differentiating. Let's do example 1, which is to differentiate this function. Y is equals to 2x minus 4x to the power 7 over x. Do you remember the steps? First, we separate the terms. They are separated by the minus sign, and each is written with the same denominator x. Now you have equals 2x over x minus 4x power 7 over x. Next, simplify. We do this by cancelling out the x, and 2x minus 4x to the power of 6 remains. Now we differentiate as usual, and as usual means applying our differentiation laws, which means the constant 2 becomes 0. The exponent of 6 is multiplied by the coefficient, and to give the derivative as negative 24x to the power of 5. There, we are done with the first one. Let's go straight to the next example. Example 2. Differentiate y is equals to x cubed plus 2x over x. Step 1. Separate the function into two fractions. It becomes x cubed over x plus 2x over x. Step 2. Simplify by cancelling out x. Now we are left with y is equals to x squared plus 2. And we can do step 3, which is the differentiating. First, the constant of plus 2 becomes 0. Now multiply the exponent by the coefficient and deduct 1 from the exponent. The result is dy dx is equals to 2x to the power of 2 minus 1 plus 0, which is equals to 2x. That was super. Well done. Let's tackle the last example with separating and simplifying. We have to differentiate y is equals to 6x to the power 4 plus 4x cubed minus 3x squared minus 2x over 3x. By now, you know the three easy steps, right? 1. Separate into, in this case, 4 separate fractions. Now it looks like this. Equals to 6x power 4 over 3x plus 4x cubed over 3x minus 3x squared over 3x minus 2x over 3x. 2. Simplify by cancelling out x in the numerator and the denominator and dividing. Can you see me doing it? 3 goes into 6 twice with the 2x cubed, 4x squared remains over 3. The third term is x, and then there is a negative 2 over 3. Now we are left with equals 2x cubed plus 4 over 3x squared minus x minus 2/3. Now we differentiate. So we put our dy dx in front to show the derivative and differentiate each term. That's right. The constant negative 2/3 becomes 0. Multiply each exponent by the coefficient and deduct 1 from each exponent. Dy dx is equals to 2 times 3x squared plus 4 times 2 x over 3 minus x to the power of 0 minus 0. And now we simplify more and get dy dx is equals to 6x squared plus 8 over 3x minus 1 minus 0. There, finally our derivative is equals to 6x squared plus 8 over 3x minus 1. Yo, one more section and you've got it. Learners, now you know more about differentiation of a fraction. Let's do an example where there are roots. To differentiate roots, rewrite the function with fractional exponents and apply the usual power rule of differentiation. We will do these 3 examples and then we are done. The first one, find the derivative of f of x is equals to square root of x. We know that the square root of x can be written as x to the power half. But sometimes it is just best to memorize and remember that square root of x is equals to x to the power of half. We continue. Now the usual steps of differentiation applies, meaning multiply the exponent half by the coefficient and it now looks like this. Half times x to the power of half minus 1. Well, half times x is half x and the exponent half minus 2 over 2 leaves minus half. That's example 1 of 3 done. Example 2 on differentiating roots. F of x is equals to 2 square root of x cubed. First write the function without the root sign. Use a fractional exponent. F of x is equals to 2 square root of x cubed becomes 2 times x to the power of 3 over 2. And now that we have an exponent for the term, it's plain sailing. Meaning we now apply usual rules of power for differentiating functions. You know the steps well. Go ahead on your own and get to f prime of x is equals to 2 over 1 times 3 over 2 x to the power of 3 over 2 minus 2 over 2. Cancel the 2's and the answer is 3 x to the power of half. That was great, learners. Now let's put our hands and heads together for the last problem of the day. We have to differentiate this root. F of x is equals to 4th root of x. Step 1. That's right. Write the function with a fractional exponent. Now it is equals to x to the power of 1 over 4. On to the power rules of differentiation, which you know well by now. Multiply the exponent by the coefficient and subtract 1 from the exponent. F prime of x is equals to 1/4 x to the power of 1/4 minus 4 over 4 equals to 1/4 x to the power of negative 3 over 4. or the satisfaction of mastering maths. Viewers, thank you for watching our lesson today, the final one in the series of 5. I hope it will make you feel more confident with differentiation. Before we say goodbye, let's have a summary of what we have covered today. In today's lesson, we have seen that in order to differentiate functions that have a fraction, we have to write the function as separate fractions with the same denominators. Then simplify each fraction until there is no denominator. Apply the usual rules of differentiation to each fraction. To differentiate a function with roots, rewrite the function with fractional exponents and apply the usual 3-step power rule of differentiation. Thanks for viewing. Good luck with your maths exams. Bye-bye.